Now let's talk about rational exponents. If we have a radical expression like the square root of x, and as you know, you can put the index 2 there and you can also not put it there. For square roots, it's not mandatory to put the index, but we always know if there's no index, it's a square root. And if we have this as a radical expression, we can also write it as an expression with a rational exponent. Rational exponents are exponents that are written as a fraction. Remember, rational numbers are numbers that can be written as fractions. Rational exponents are exponents that can be written as fractions. You may have seen this before and maybe not, but why is this possible? Why can we do this? Well, let's think about it this way. If we had the square root of x squared, we know square root and squaring are two operations that cancel each other out, and we end up with our good old x. Now, writing this as an expression with a rational exponent, we would say x squared to the power of 1/2, making the radical an exponent of 1/2, and following our powers rule, which you remember from algebra 1, we can now go ahead and multiply those two exponents. 1/2 times 2 is 1, and we do end up again with x to the power of 1, or just simply x. So it does work out. And then if that works for square roots, it also of course works for other roots. Then the cube root of x must be able to be written as x to the power of 1/3. And that brings us to the next rule down here. Consider a to the power of m over n. We can rewrite that as a to the power of 1 over n, that is the radical part, raised to the power of m. We can also then completely write it as a radical expression, the nth root of a to the power of m. So we can go back between writing an expression as a radical expression or as an expression with a rational exponent. Well, looking at our example here, 16 to the power of 3 over 4, we can say this is the fourth root of 16 raised to the power of 3. Now, please note that you could equally write this as 16 cubed and take the fourth root of that. Both these are equivalent. Both ways work. But I recommend we always start with the radical first, because that way we get the numbers to become smaller before we have to multiply them again and make them larger. Taking 16 to the power of 3, we definitely need our calculator for that, and we're going to end up with large numbers before we bring them back down with our radicals. So the fourth root of 16 raised to the power of 3. 16, as we know, is 2 to the power of 4. The fourth root of that, and then we raise it to the power of 3. The fourth root of 2 to the power of 4, that cancels each other out, and we end up with 2 cubed, and that is, of course, 8. And see how easy our expression has become. And we can, of course, go the other way around also. The fourth root of 8 raised to the power of 5. So we use our index 4 and our exponent 5, and we write 8. The exponent goes in the numerator of our rational exponent, and the index goes into the denominator, and this is equal to 8 to the power of 5 over 4. Rational exponent cannot be simplified, so we are done here. Okay, let's simplify the sixth root of 256. Go ahead and stop the video here and draw your factor tree for 256 in the left margin of your note page, and then come back. Hopefully you came up with the same answer as I did. 256 is 2 to the 8th power, and we have to take the sixth root of that. Another way to write this would be the sixth root of 2 times 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 2. I'm writing this out because with a sixth root we now need to find a group of 6 numbers that are the same, that are being multiplied, in order to be able to take one of those numbers out, and we are left with 2 2's underneath our radical. Another way to think about this is to say, how many times does 6 go into 8? And it goes once into 8, so 1 2 comes out, and 2 are left over. That's the exponent of our 2 underneath our radical. So now some people would maybe leave off here and not simplify any further. But now let's use our rational exponents to help us out. Let's look at this part. The sixth root of 2 squared is the same as saying 2 to the power of 2 over 6. And our fraction 2/6 can, of course, be simplified into 1/3. And therefore we can go back and can now write 2 times the cube root of 2. And that is our fully simplified answer. Let's talk about simplifying expressions with variables. Expressions with variables will always have some coefficient in there. So the first thing we need to do is we need to break down that coefficient into its prime factors. And the prime factors of 64 are 2 to the 6th power, 2 times itself 6 times, and we got y to the 6th. And let's use the shortcut trick we just talked about to simplify this radical expression, which also is reflected in the way we write rational exponents as fractions. Let's take our index and see how often it fits into our exponents. 3 goes into 6 2 times. That means 2 can come out 2 times. Nothing left. 3 goes into the other 6 again, also 2 times. So we got y squared coming out. Nothing left. Let's clean up our 2 squared, which is 4, of course. 4y squared is the final answer. Moving to our next example, let's do the same thing with our 24 first. 24 is 2 cubed times 3 times m to the 6th power n to the 4th power r to the 7th power. 3 goes into 3 once. A 2 can come out. 3 goes into 1, which is the exponent of our 3, right? The invisible exponent. 3 doesn't go into 1 at all. So our 3 needs to stay underneath the radical. 3 goes into the 6 twice. So m squared comes out. Nothing left. 3 goes into 4 once. But 1n remains. And 3 goes into 7 twice. And 1r also remains underneath the radical. So again, we can clean this up going by highest exponents. We get 2 times m squared r squared n times the cube root of 3nr. On to our last example, 243. Now that will be 3 to the 5th power. 3 to the 5th power times a to the 15th times b to the 8th times c to the 9th power. 4 goes into 5 once, so 1 3 can come out, but we will have 1 3 remainder. 4 goes into 15 3 times, with 3 as a leftover. A cubed stays underneath the radical. 4 goes into 8 twice, so b squared comes out, nothing left. And 4 goes into 9 twice as well, so c squared comes out. But here we have a leftover, a remainder, and c goes back underneath our radical. And this is basically already it. Nothing else that we can do here to simplify. And here is our final answer. Circle the previous answer nicely. And that's it for today. Well done, guys, and I will see you in class.